Hello and welcome. My name is Eduard Metzger, and today I present you the MICROSAR intrusion detection system solution. So we have a brief look at the motivation. We will walk through the concepts of the solution and its standardization in AUTOSAR, and finally see the architecture and interfaces and how the IDS solution is configured. Well, the IDS solution of MICROSAR fits into the big picture of the detection and mitigation of security event. So it's all about collecting security-related data in the vehicle, reporting this data to the backend, analyzing the data, and mitigating threats based on the analysis of this data. However, for this talk, we focus on the detection of security events on board of the vehicle. So a central concept of the IDS solution is the so-called security event, which is defined as an event that is useful for off-board forensic security analysis. And a sequence of security events can help to identify attack vectors on vehicles. Each security event has a unique event type, so that it's possible to unambiguously identify the kind of security event. It's not limited to a specific topic, but it can rather relate to diverse assets, such as the CAN or Ethernet communication, diagnostics, cryptomaterial, or even topics like smart charging communication. A security event can be negative, so for example that some ECU received an unauthentic PDU via CAN, or it can be also something positive, such as that a root certificate was successfully updated. However, it should be useful for a later analysis of the security state of vehicles. And it basically is defined at least of a security event type, which defines its name and description. And it can optionally have so-called context data, which provide additional information about the security event that actually happened. Context data can, for example, be a PDU ID, or it can be a certificate number, or anything else that helps in the analysis of security events. So let's have a look how security events are processed on an ECU. So the basic idea is that there are a number of security sensors available on the ECU, and the security sensor is basically any piece of software that can report security events. So it can be a basic software module, for example, but it also can be a software component that reports security events. These security events are reported to a new AUTOSAR module called the Intrusion Detection System Manager. The IdsM can then filter these incoming security events and drop any security events that probably are not relevant. The remaining security events are called the qualified security events. And these qualified security events can be further processed, either by pushing these security events to dedicated diagnostic event memory called the security event memory, or by pushing the qualified security events via the bus system to another ECU, which hosts an intrusion detection system reporter. And this intrusion detection system reporter is connected via a channel to the security operations center, where the security events are further analyzed. So how does a security event actually look like after it was qualified by the intrusion detection system manager? Of course, it still has its security type ID, which identifies the name and information about the security event, but it also gets an IdsM instance ID, which actually encodes the ECU by which the security event was reported. It also includes a qualification account that describes how often the security event was reported to the IdsM before it was qualified. Each qualified security event can optionally have a timestamp, the context data at the point in time when it was qualified, and optionally it can have an end-to-end signature. So a cryptographic signature which can be evaluated at the Security Operations Center to make sure that the security event is authentic. So how is actually this concept deployed in a vehicle architecture? So here you see an example vehicle architecture where these yellow nodes represent high power ECUs, which do important central processing tasks. The blue nodes represent typical domain controllers, which coordinate the tasks of the domain. And the white nodes represent standard ECUs, which take specific tasks like, for example, engine control or internal lighting. So the most basic deployment of the IDS architecture includes that you have on one node an intrusion detection system manager, a number of security sensors, and a security event memory. With this configuration, you can report the local security events of this node and push it to the security event memory of this node. With the next level, you could decide that you want to have a backend connection for your IDS, which requires that you deploy an IDSR on a node which actually has a backend connection. If you decide that further nodes are security relevant for your system, you can freely deploy the same architecture on other security related nodes so that you get a fully distributed IDSM. The complete system is very configurable and scalable so that it can be adjusted to meet the performance needs of also smaller ECUs. So with this architecture, you can really realize a distributed IDS. So for example, the standard nodes can report their qualified security events either to their local security event memory, or they can push it through the vehicle architecture to the IDSR, where they are collected centrally, and further information can be added, such as a vehicle identification number, or the mileage, or the geoposition of the vehicle, and then the security events are reported to the Security Operations Center. The complete concept of a distributed IDS architecture was standardized in AUTOSAR in 2020. And part of this standardization was the module IdsM, the Intrusion Detection System Manager, which handles the buffering, qualifying, and processing of onboard security events. A further element of the standardization was the protocol for the transmission of qualified security events from a local IDSM to the IDSR, and also a number of security events for selected basic software modules have been standardized. Examples are security events for the key manager, for the DCM, for SecOC, the CAN interface, Ethernet interface, and TCP/IP. And also a new format for describing IDS properties was introduced, the so-called security extract. How does the IDSM now integrates into a standard AUTOSAR architecture? So the IDS is allocated in the crypto services cluster, basically on the same level as the key manager and the crypto service manager. It can have a number of interfaces to other AUTOSAR modules. So for example, to the basic software modules, which are reporting security events to the IDSM, but also to applications which report application-specific security events. Furthermore, it has interfaces to the BSWM for state management and to the SDBM for timestamps. Qualified security events can then be sent via the PDU router by using the IDS protocol, or they can be stored in the diagnostic event memory. Our implementation of the NVM allows to protect the NVM blocks which contain the security events via the crypto stack. So for example, you could apply a signature or a MAC to your NVM block. As a MICROSAR module, the configuration of the IdsM can be done via the DaVinci Configurator, so you don't need to have any external or IDS-specific tooling. So with the IdsM configuration in DaVinci, you can define your security events, you can connect your security events to the reporting modules, you can define filter chains, and of course, all basic properties like timestamping or signatures. Okay, thank you very much for your attention and watching this presentation. If you have any further questions regarding the IdsM module and the available security events and sensors, don't hesitate to contact us at Vector Informatik.